Hey everybody, welcome to another Probably Private. I'm Catherine Jarmal, and today we're going to talk a little bit about the first steps when you get your new machine, assuming that you built your machine yourself, or assuming that you want to change the operating system. Now, all of this is also going to be in a blog post, so you can check it all there to follow step by step. But the first thing that I would recommend you taking a look at is the combination of what GPU you have and what operating system you want. Take a look and see, are there drivers available for this? Now, what are drivers? Well, it's a way that essentially the hardware of whatever your GPU is, or if you're using another type of chip that accelerates things like Apple Silicon, it's basically making sure that the operating system can talk directly to whatever that chip is, or in the case of a GPU, the card that then also has chips, right? And this is going to let you both send the data over back and forth between them and make sure that your workflows that you want to run with the machine learning you want to do, that all of that functions properly. And a driver is often proprietary, so it's often kind of the latest drivers for whatever operating system and GPU that you have are often proprietary. And that's quite unfortunate, right? There's people that are trying to work on things like open drivers, but because the chip designers or the GPU designers often want to keep the secret sauce of whatever it is they're doing on that piece of hardware for themselves, it means that the instruction set and the drivers that most optimally use that are often proprietary. I myself, I try to use open drivers if they work. But for example, the machine that I showed you in the video of setting up your own, take a look at it. That machine actually had that GPU had a new architecture, a new memory architecture, and none of the open source drivers that I use normally in Linux actually supported that architecture yet. So you might run into that same problem if, let's say, the GPU that you're getting is quite new. If the GPU is older, it might be useful to try out if you're using something like Linux, to try out some of the open source drivers. Not only does this help improve open source code if more people are using it, but also it, puts pressure on creating more open source drivers and less proprietary drivers. So I just want you to look that up. Again, I don't think that you need to learn Linux to do deep learning on your machine. Of course, if you're already learning Linux or if you already know Linux from working in the cloud, I would recommend using some sort of Linux flavor because this allows you to use a bunch of the other types of things that we might want to use. But once you've had a look, and I would search around, especially if your GPU is new, what is the driver that I'm going to need for the operating system that I feel comfortable in for running a machine learning workload? And only then, start getting your operating system set up. The next layer that you're going to want to get installed is obviously Python is kind of the go-to language in a lot of ways for deep learning. Of course, there's libraries in other languages, but probably some of the best libraries for the past 10 years and certainly for the foreseeable future are Python libraries. So get Python running however you like to install and run your Python. So I personally use Conda, and I know a bunch of people now use UV, but get whatever it is that you like to manage your Python environments and your Python versions running. And at that point in time, you probably also want to install your GPU software. So you might have heard of CUDA, which is a GPU software provided by NVIDIA for NVIDIA hardware. And CUDA is obviously a likely choice if you're using an NVIDIA GPU. But there's also ROCm for AMD. And the cool thing is for Apple Silicon, you don't have to do anything because the way that they've architected it, it means you don't have to. There is a language you can program in for it, but for the use case that you're probably going to do, you're probably not going to have to install anything specifically for Apple Silicon. And what is that doing? Well, it's essentially, we can think of it as the software layer for how we should take something from, let's say C++ or Python and C++ and translate it down into, or be able to compile that down into instructions that the GPU can actually run, again, via that driver. And so that GPU software is essentially how we program for the GPU. Now, the nice news is you probably don't ever have to write CUDA yourself. If you want to, you can. And you can do so very specific to the type of architecture that you have, for example, and get some efficiency out of that. Or you can even write other languages that compile down. So I'll put a link, but I was recently at FOSDEM hanging out in a dev room that's been there for 2 years called AI Plumbers. And there's some really cool stuff that people are working on there to support many different types of chips for things like machine learning and tensor operations. And they're definitely also, trying to deproprietarize a lot of these problems that we have with drivers, and then the problems that we have with what we call cross-compilation. So I write, let's say, Python, but then I can run it on 2 different types of GPUs, on 3 different types of chips. So there's a lot of cool stuff happening in there, and I expect to see some change there. But for you as a user, you're going to get Python set up. You're going to get some sort of GPU software, so for whatever type of GPU that you have. And again, there's a few open ones there if you want to try them out. But it is generally recommended if you use NVIDIA to go with CUDA, and if you use AMD to go with ROCm. And what I always recommend is, at least if you're a CUDA person, I have a bunch of NVIDIAs here at home, use the latest CUDA. Now, you might be like, but the latest CUDA doesn't have all these other special things that I want. Or maybe the latest CUDA isn't supported for your GPU, which is fine, although usually that's not the case. And why I say that is because what's going to happen is you're going to get a bunch of things running. At some point in time, the CUDA version you're on is going to be old, and you're going to have to upgrade CUDA. And at that point in time, it will seem like everything breaks. And that's unfortunately because what we have right now in a lot of deep learning setups is very intertwined, essentially like overreaching layers that we have in our stack. So sometimes you're going to probably be running PyTorch at some point in time. Torch, when you install it, is going to ask you, what are you using Torch for? Show me what type of CPU architecture you have and what type of GPU you're using. And then let me recommend you a Torch version based on that. Why is that? It's because when we think about this, all this way down, I'm working in Python. That needs to eventually go down to something that CUDA can understand. That needs to eventually be compiled down to something your specific driver can understand. And then we're actually running it. And because of so much interdependencies, as you can imagine amongst that, and because it's been so proprietarily driven, it means that when you upgrade your CUDA, you're probably going to break a bunch of your Python virtual environments. So that's just going to be the pain point that you have. That's why I start with the latest CUDAs so that you can use it for a long time. And then one weekend or one evening or one day, you're going to decide today is the day that I break everything. You're going to upgrade CUDA. You're going to get your virtual environments reinstalled, working the way you want. You're going to rerun your workload and it'll be fine. I promise you. So make sure you're kind of building virtual environments and your Python around what it is you're trying to do. And if you're just getting started, I recommend just starting with either Hugging Face, Python libraries, and get working on those, or a specific Torch package you're looking at and get running on those, and make sure that that, again, goes all the way down. It works well for your operating system, for your CPU, for your GPU. And the nice thing is most of those libraries now will have a recommendation for you directly on the page. So I'm going to share with you this page from PyTorch that helps you decide exactly what it is you need to install. So now you have your drivers installed. You have your GPU software installed. You have your Python environment management installed, whatever it is you're doing to do that. you have your operating system installed, right? All of that is installed and running, and you're going to be able to run your first deep learning job. So you might want to just start with something simple, like what we've been talking about, running an inference workload via something, making sure that it's running on the GPU. So that's how you make sure and know my driver's working, my GPU software is working, is I can run something, it runs well, I know it's running on the GPU because it says so, and I can see the beauty of hardware-based acceleration by doing so. And final tip for you, a lot of you might be thinking, why don't I do this in Docker? Well, there's many reasons why, and one of them is the complexities that I just laid out. Essentially, if you're using Docker, you're just adding one more complexity on how your operating system interacts with the code that you're running, which then interacts with your hardware. So it's just not a good fit for machine learning. It's plenty good fit for other things, but it's just not a very good fit for machine learning for a lot of reasons. Unless you're a super, for some reason you're so into Docker you can't do it any other way, sure, figure it out. I wish you luck on your journey. But what I highly recommend doing is starting to think about virtual environments, which is a Python essential way of thinking through something like Dockerizing your setup, and to start to think through virtual environments and versioning those for your different projects. And probably what's going to happen is first you're going to start with one virtual environment where you're kind of doing most of your work. But what I would actually recommend is you start to slice your work in very small spaces where you say, for this, I'm doing this image to text pipeline and I'm running it in this virtual environment. And then I'll actually, even if I'm programming this in software, I'll actually change virtual environments, get it running, and hand over to another virtual environment, which of course you can do, or you can yourself change those workflows. So I hope this helps demystify some of the ways of getting started with your own hardware and getting it running. Again, I have an entire article which will go through even what commands you can run to make sure that you're running things on the GPU, and give you some links to point towards some obvious places like CUDA installation, Torch installation. And I look forward to hearing from you how it goes. And if you have any tips, if let's say you're more of an AMD person or you use a non-Linux operating system and you have any tips that you want to share with people, please feel free to put them in the comments. And let me know when you run your first job on your GPU. All right. See you next time.